All right, so the end of Algebra 2 lesson 5.2. We're looking at factoring a quadratic and then using that to solve. So we looked at standard form quadratics where you're looking for factors of A and factors of C that the combination are going to give you B. Okay, so we looked at that already. With factoring, we have a lot of trial and error. Okay, you have to decide what works first or figure it out. And sometimes it's not an easy look. So you'll have a lot of trial and error. There are some expressions that have a shortcut, and these are special patterns. And we kind of have looked at them already. We looked at them as when they're in factored form, going and putting them in multiplied out form without having to FOIL. But they are the difference of two squares and a perfect square trinomial. Okay, so the difference of two squares is kind of exactly what it sounds like. It's a difference, and the terms are squared. So you're looking at something like a squared minus b squared. Two terms that are both something squared, and it's written as a difference. You can factor that as the first plus the second times the first minus the second. So a plus b times a minus b. Okay, so kind of an example that we can see would be something like 4x squared minus 25. Okay, this falls into this special pattern because there's two terms. It's being subtracted. I can write the first one as 2x quantity squared minus 5 quantity squared, because 4x squared is 2x to the second power and 25 is 5 squared. Then I can say, okay, this falls into the difference of two squares, so I can factor that to the first one, so 2x plus the second times the first 2x minus the second. So 2x plus 5 times 2x minus 5. Perfect square trinomials have three terms because it's a trinomial. The first one is squared, and the last one is something squared. And then the middle, and we can have plus or minus, is going to be twice the first times the second, or the last. And then it's just a matter if it's plus or minus here. When it's a perfect square trinomial, it's easy to factor because you can write it just as a binomial squared, and it's the first and the second, and then if this middle term is addition, it's plus. If the middle term is subtraction, it's minus. So a plus b squared or a minus b squared. Okay, so if I have x squared plus 8x plus 16. What you need to do is you need to look and see, can I take this first term and write it as something squared, which you can, and then can I take this last term and write it as something squared, which you can, 4 squared. Okay, then you want to check to see if this middle term is twice this first one that's squared times the second one that's squared. So 2x times 4. And they are. So that's a perfect square trinomial. So we can say, okay, that's going to factor to the first plus the second squared. And it's plus because it's plus here. If this was minus, you would put a minus there. Okay, so those are our special patterns. that you want to check first before you start looking at the factors of everything. Okay, so 16y squared minus 225, 4z squared minus 12z plus 9, and 36w squared plus 60w plus 25. We're looking to factor these. Okay, the first one, there's only two terms, so it leads us to believe it's the difference of two squares. So I need to see if I can write them as two quantities squared. So 16y squared, well 16 is just 4 squared, y squared is y squared. So I get 4y quantity squared. 225 is just 15 squared. So I can write it as 4y squared minus 15 squared. So it's a difference of two squares, so it's going to be the first plus the second times the first minus the second. So 4y plus 15 times 4y minus 15. Okay? Then when it's three terms, you look at the first and the last and see, can I write this first term as a single quantity squared? So 4z squared is just 2z whole thing squared. 9 is just 3 squared. Then I need to see if 2 times this first times the second equals the middle term. So 2 times 2z times 3. Well, 2 times 2z is 4z, and 4z times 3 is 12z. So it is a perfect square trinomial. So then I can factor it and say, well, it's going to be a square of a binomial. So it's going to be the first and the second, but then it's subtraction. So it's going to be subtraction in your binomial. So 2z minus 3 quantity squared. Okay, same thing here. Can we write 36w squared as one quantity to the second power? And you can. So it would be 6w. 25 can be written as 5 squared. Then we're going to check to see if 2 times 6w times 5 is the same as 60w. And it is. So we have another perfect square trinomial. So it's the first one and the last one. And then it's going to be plus because it is plus in the trinomial. Okay? So that's how we use these special patterns. One other thing to note is that when you're given quadratics, before you start seeing if they're, well, before you start trying to factor, you want to look to see if you can factor out a monomial. Meaning, do all terms have something in common? If they do, factor it out first and it'll make it easier to factor. So we're looking at something like 14x squared plus 2x minus 12. Okay? So if we look, we can say, well, do they all have something in common? They don't all have an x, but I can take a 2 out of everything. Meaning I can divide everything by 2. So 14x squared divided by 2 is 7x squared. 2x divided by 2 is x. And negative 12 divided by 2 is negative 6. Then I can look in the inside here and try to factor that. So we're looking at factors of 7, which are 1 and 7, and factors of negative 6. So 1, negative 6. Negative 1, 6, 2, negative 3, negative 2, 3. We're looking for a combination that's going to give us a positive 1. So I have to just differ by 1, right? So 1 and 1 is 1 plus 7 times negative 6 doesn't work. But 7 times 1 is 7. And 1 times 6 is 6. a 1, and a 6. Then you just have to figure out positive or negative. So you want the 7 to be positive and the 6 to be negative because you're going to get a 7x minus a 6x. So it's completely factored. Okay? Once a quadratic is factored, that can help us solve the equation. So you're going to use the zero product property to solve. And what the zero product property says is that you have A and B are real numbers. If their product is 0, then one of the factors has to be 0. So either A or B has to be 0. So then that works to solve a quadratic, because if I have 9t squared minus 12t plus 4 equals 0, I'm going to factor this quadratic, and that's 3t and 3t, then 2 and 2, so plus 2, or no, minus 2, minus 2. Then it's factored, so we have two products, so a product time, or one term times a second equals 0, tells us that one of those has to be 0. So I can factor and then set each binomial equal to 0 and solve. So this one I get the same thing both times, so I get t equals 23. We want to solve 3x minus 6 equals x squared minus 10. Okay, so the first step is to put everything on one side. So I'm going to subtract 3x and add 6. And I get that 0 equals x squared minus 3x minus 4. Then I'm going to factor. So factors of 1, right? Then factors of negative 4, that add up to negative 3, and that's 1 and negative 4. So we get x plus 1, x minus 4 equals 0, okay? Then using the zero product property, we get either x plus 1 equals 0 or x minus 4 equals 0. Then we can solve for x. So I'm going to subtract 1. So I get x equals negative 1. And I'm going to add 4. And I get x equals 4. So two solutions for that problem. And that is the end of 5.2 now. So just make sure you find your new schedule.